How do block diagrams simplify feedback control system design? Imagine trying to understand a complex machine with many parts all working together. It can be confusing and hard to see how everything connects. That's where block diagrams come in. They turn complicated systems into simple, visual maps. This makes it easier for engineers to see how signals flow and how different parts interact. When designing feedback control systems, clarity is key. Block diagrams give a clear picture of each component, like the controller, the plant, and the feedback loop. Each part is shown as a block with a transfer function, which describes how it changes signals. For example, the reference input is what you want the system to do. The controller adjusts signals based on the error between the desired and actual output. The plant is the process or device being controlled. The feedback element takes the output and feeds it back into the system to compare with the input. The summing point combines the reference input and feedback signals to produce the error signal. The output then shows the system's response. By arranging these blocks and their connections, engineers can see the entire system at a glance. This helps them identify how signals move through the system, what happens at each stage, and where issues might occur. Block diagrams also make it easy to perform algebraic operations. Engineers can combine blocks in series or parallel, or reduce complex parts into a single equivalent block. This simplification helps in calculating the overall transfer function, which predicts how the system will behave. Knowing the transfer function is essential for designing controllers that keep the system stable and responsive. Feedback paths are also clearly shown in block diagrams. This helps engineers understand how feedback influences system stability and gain. They can see if the feedback is negative or positive and how it affects the system's dynamic response. Troubleshooting becomes simpler because you can isolate specific blocks or paths to find issues. Modifying the system is also easier. If you want to change how a part works, you can just update the relevant block and see the effect on the whole system. In electrical engineering, block diagrams are used in many areas, like motor control, signal processing, and power electronics. For example, in controlling the speed of a motor, the block diagram helps design the feedback loop that adjusts the motor input to keep the speed steady, even if there are disturbances. Overall, block diagrams are a fundamental tool in feedback control system design. They turn complex mathematical relationships into visual diagrams that are easy to analyze, modify, and optimize. This makes designing efficient, stable control systems much more manageable and straightforward.